number 9, June 2018. All right, let's go, Meg, and everybody else. First thing here, I'm given AB is parallel to DCF, this whole line here. All right, so I have different types of angles working there. I'm also told that EDA and CBG are parallel, all right, and they're drawn in, which statement is always true. Well, I can tell you right now, I'm probably going to eliminate those two. Why am I going to eliminate those two? Because to prove a pair of triangles congruent, I at least need a pair of sides. And there's no way I'm going to get pair of sides from parallel lines. I can get a ton of angles, but probably not a pair of sides. Good so far? Because remember, angle is not a way to prove triangles congruent. Good so far? And I'm hoping neither one was the answer. All right. So is it these two, this pair similar or this pair similar? All right. Well, let's go to BAG. Let's see. BAG and AEB. Those two. All right. Let's highlight them real quick. And AEB. This one right on top. All right, let's see, congruent angles that are in those. Oh boy. I do not see any, I don't know. Anybody see any congruent angles in those two that I highlighted to be similar? I'm trying to, the parallel lines to get me any. Yeah, maybe these right here. Because here, there's the parallel lines, these two right here, alternate interior. Right? And that's really about it, because I can't say these two. Everyone see why I can't say these two are congruent, because they're alternate interior. Which two lines would need to be parallel for these two alternate interior angles to be congruent? Bless you. EB and AG would need to be parallel, which they're not. So I can't say those are. So this looks like the only pair I could prove congruent, unless you see another pair. Good? Okay, and then I go to the other pair, which is these two up here. AE, is it this one right here? DEF, and the bigger one. Right here. Why are these two similar already? Well, they both share angle E. Good. And then what type, since these lines were parallel, what type of angles are these right here? Corresponding. I could have picked these two as well or corresponding. So there's angle right there. Okay. Good deal. And I don't, there we go. Next up, any other part ones here we want to go over? Maggie? 14, everybody. Partition. So if anybody had this topic, we're doing it now. It's a partition question, number 14. Okay, yep. We're breaking it up into a ratio of 2 to 3. How many congruent parts then am I breaking that line up into? 5 congruent parts, because that's huge. All right, so the way we did it, we took the x-coordinate first. What are the x-coordinates of D and E? So on the x-axis, you're going from -4 to +1, which is a distance of what? 5. That's perfect, because I'm going to divide that distance up into 5 equal parts according to my ratio. So that means if you want to break it up into 5 equal parts, you go 1 unit every time. But that's not what the ratio is asking me. It's 2 to 3. So I don't want to go just once. I want to go twice. So I multiply this 1 by 2 because I'm going to go twice. So I'm going to go 2 total units. From where was my starting point on the x-axis? -4. So if you're on the x-axis, you're at -4. You go 2 to the right. Where do you end up? You end up at -2. And I realize the problem's over because there's only one multiple choice that has -2 as an x-coordinate, but let's do the y's because I've seen this in part 2s as well. What are your y coordinates? -2 going to 8 for a total. Now you're on the y-axis. So -2 go up to 8. How many units did you go? 10. And that's great too because that's divisible by 5. Now you go 2 units. And now here's where kids get a little confused. We are still using the 2 here. This isn't reserved for the x, and that's not reserved for the y. Okay? If you want to go here, just so you know how this works, all right? 2 to 3 is when I go from D to E. 3 to 2 is if I go from E to D. That way. Okay? It's not an x and a y ratio here. All right? I'm still going to multiply that 2 by the first number in the ratio, 2. So now I'm going to go 4 units from -2. So everyone go up 4 from -2. Where do you end up? +2 for a coordinate of -2, 2. Choice 2. Anybody know how long you have to, required to stay for this exam, no matter if you finish in 5 minutes or 10 minutes? 2 hours. And you have 3 total to take it. Why am I telling you this? This might be a great time at the end to go back. You have a scrap sheet of graph paper on the back of your exam. Graph D and E, connect them with the straight edge, and see if -2, 2 is on the darn line. Because if you graph your line, here's D, here's E, and all of a sudden your partition point's out here, something went wrong. Okay, the partition point should land somewhere 2/5 of the way from D. All right. All good there. Maggie, you good? Great. Next, anything else? Part 1's here. Before we go topics, part 1's, because I'm putting this to the rest, not coming back to the June 18 exam unless you're coming in to review it with me. Anything else here? Meg. Okay, you got to tell me what was the issue with 22 so I can start somewhere here with you. Okay, this is a formula you got to come in knowing, and I'm not picking on Meg here. I don't know, because I don't know if I've said it or not. When you're doing these Regents review problems, what should you have right next to you? The cold hard fact sheet, because I believe area of a sector is in there, or the length of an arc is in there. All right, because we had to find the length of arc B. That's just a formula. Okay, that's a formula not on the reference sheet, which says the following. It's the measure of the arc over 360 times circumference, pi d, for the length of the arc. And now this just becomes plug and chug. So now it's 120 over 360 times pi d would be 12. Now, I don't see that in my multiple choices, but I do see 120 over 360 reduced, 1/3 times 12 pi. Okay. Yes, hi, Liz. In 1 second, yes. Before I get there, just while I'm on this topic, because I've seen this too, let's say I wanted you to find the area of this sector right here. How does this formula? It's the same formula except for how's it change? Not circumference, area, pi r squared. Okay, so that's sector, and length of an arc is with circumference. All right, just a little FYI there. All right, Liz, 24.
Yeah, well, I know how to do it if it's like on the line, but what if it's like not on the line? Like if it's on the same line?
So okay, so this one was on the line?
Yeah.
Okay, so it's the same line, right?
Yeah.
That's the
I don't know how to
okay, if it wasn't on the line, good question. Very good question. What am I? Let's see, grid. I need the grid. There it is. Okay, just so everyone knows what Liz is asking here, all right? She knows that, okay, if you ask me to dilate this line by any scale factor, 2, 1/2, whatever, and the point you want to dilate around is on the line, what's your image? Same line, okay? Now her question is, all right, well, what if they put it off the line? Which is a great question. Here's what I would probably do, Liz. I would take 2 points that I definitely know are on the line. Okay, 2 points I know are on the line. Let's say that, because the scale factor shouldn't be that bad. So let's say it's a scale factor of 2. Okay, so I would take each point right now and go, oh, all right, up 1, 2, 3, 4, 5 over 2, go up 5 over 2, find the new point. Do the same thing with another point you know that's on the line. Let's see, in this case, I would go down 1, 1, 2, 3, 4, 5, 6, 7, down 1 over 7. Good so far? Now you have 2 points. So now you can find the slope and find the y-intercept of those 2 points, and then write your new equation. That would be my best way to go about it. You see what I mean by that? Okay, so use your slopes to find 2 new points, find the slopes between them, and then find the y-intercept by plugging one of them into y equals mx plus b. Okay, that's the best way. Good question. Anything else here on June 2018 before we close this one up as a class anyway? Anything else? Okay, June 2018, now closed. Let me open it up to any topics you've been thinking about. We are into day 3 of our review here, day 3. Vincent, your topic here. What do we need to start thinking about? Angle of depression, you got it. Okay, here we go. Angle of depression. We're talking about a right triangle, probably a sine, cosine, tangent, SOHCAHTOA problem. All right, if I see angle of depression. Angle of depression is when you're at the top of something like a building looking down. All right, but you have to remember, you have to remember that this is not the angle of depression. The angle of depression is you looking down from the horizontal line of sight right here. Here is angle of depression. So that is the angle where you put 53 degrees, whatever the angle of depression ends up being. You want to put it outside. Now, we talked about this when we did this unit. How do you make it inside? How do you make an angle inside off of it? Because if you're going to use sine, cosine, and tangent, the angle's got to be inside. So how can I use this depression to get an angle inside? 1 of 2 things. Subtract it from 90 and get the angle right next to it. Or it's also equal to this one, because they're what type of angles? Alternate interior. And while we're on the topic, anybody remember what this angle was called if you're looking up at something now? That's angle of elevation. There we go. Okay, so depression is outside the triangle, but it's also equal to the elevation angle. So we good there, Vincent? Anything else here, topic-wise? I know you got the rest of the week too, but you want to start thinking different topics here. Hi, Maggie.
The one where the sine of x equals the sine of one angle is equal to the cosine of the other angle. Oh yeah, when they're complicated.
I got it. I know what you're talking about, and don't start chiming in because you're absolutely wrong. All right, you're totally wrong. You have no idea what she's talking about. Yeah, there's usually one on every exam here. Yep. Where do you think I got all my test questions from? At least the multiple choices, anyway. I'm trying to just see here, Matt, the one I just gave you, if there's one on there. No. Eight on this exam or June? The June one?
2018.
Number?
Number 8.
Okay, so we're going back to June. Looks like number 8. I think this is what you're talking about. Okay, sine and cosine, when are they equal? I know a lot of people see this. It's one of the, it's number 8 on the multiple choice. So you probably think it's probably one of the easier ones. So I'll just set 2x plus 4 equal to 46. And I'm sure the answer is there, and that's what they want. Okay, but that is not the case. Sine and cosine are only equal if their angles do what? Add to 90 degrees. Okay, you can go on your calculator right now, do the sine of 50, and it's going to be equal to the cosine of 40. Okay, so this will be plus 46 equals 90. Sine and cosine will only be equal if their angles add to 90. Two x plus 50 equals 90. 2x equals 40, x equals 20. Also, hopefully you won't fall into this being honors level, but desperation mode. This is multiple choice. You have a calculator. You plug in 20 for x. You do the sine of that angle. Is it the same decimal as the cosine of 46? You just start plugging them in and see when they're equal. Okay, that's another way around this problem. Not the way I'd like you to do it, but if it gets the job done, who cares? Maggie, we good? Okay, good question. Anything else here? Topics, it's your show before I get to some topics that I've picked out. Nothing else. Oh, Roman, yes. Big circle question? Okay, you got it, boss. I don't have one in the Regents, so if you guys want to do this with me, you're going to have to copy it down. So I have not. I'm going to go over one because you never know which one of the parts will be on the test. There's always some circle theorem on there or some circle fact at the end that you got to know. Is that whole times external? Is that 1/2 the difference, 1/2 the sum? I've never seen a big circle question on here, but certainly one of the single theorems could be on there. So where's the, actually I got it on my desktop, the big. Okay, where are the circle? There's a ton of stuff on here. This is what happens when you guys all email me about stuff. Congruent coordinate proof, partitions, law of signs. Where are those circle questions? Big circle questions. Okay, here we go. Some of you guys remember these right here, all 46 of them. Roman, 1 through 46. Let's go, boss. 23 it is. There's 23. I'll cut it out. You guys do what you want. When you want to do whatever you want with it, I'm just going to label the arcs they give me. Okay. Correct. This is not a party hat. UP is not equal to RP. They have to be formed by tangents, not secants. Good question here, Roman. Good question. This covers a lot of the theorems here. Okay, I'm going to get started here. So I know two arcs and an angle. Two arcs and an angle. It's asking me for arc UR. That's a problem because I would like to know arc TS, so I could just subtract those three from 360 and get UR. Can I find TS? I can find TS. Arc TS. What type of angle was TRS? Oh, here we go. It's been a while. That's inscribed. So that's half its arc. So its arc should have been, TS should have been 100 degrees. Everybody good? 100? Did anybody else think it was 5 and not just want to ask? Okay, there's your company right there. Way to go. Yep, that says a lot. All right. And this is probably a good time to mention it. I probably should apologize to Orion for last week for cutting him off not once, but twice as far as the summer plans, because believe it or not, Orion, a couple of your classmates came up and defended you and said, you know, that was a little, put me in my place and said it was a little rude of me to do that to you. So do you want to finally tell your plans to the class? I'm giving you the opportunity. Classmates defended you, put me in my place, which is pretty rare, but it is what it is. I felt bad afterwards. So your summer plans? Last opportunity here, summer plans? Still don't care? 3 in a row? Do you think your classmates care about your summer? No! No! 3 in a row. Come on. Your classmates cared. Nobody came up to me and told me that. Come on. Get out of here. Yes, get out of here. Get out of here. All right. Now people are feeling bad. All of a sudden, after number 3, people are feeling bad. All right, let's finish this, please. Let's finish this. Measure of UR. Now you have all the arcs you need. We'll just take 360 minus 100 minus 80 minus 120. Anybody? You guys have the calculators. Want to try to get that one real quick for me? 60? Just 60? Okay. I'll believe you guys. 60. All right, moving on. Angle SUT is the next one. Angle SUT. Okay, here we go. What type of angle? SUT. It's inscribed and it's drawn to which arc? ST, which we just found was 100. So a half of 100. That is also 50 degrees. Now, I'm trying to get you ready for anything you could see here. So here's my next question. Let's say we're doing a proof, and you wanted to put these two angles are congruent. There's no measurements in a proof. What's your reason going to be? Come on now, dig deep here. If you wanted to say TUS and SRT are congruent, Maggie, what's my reason? Perfect. Don't say two angles. Two inscribed angles drawn in the same arc are congruent. All right, nice job, everyone. Part C is asking me now, angle P. Make this easy on you. Where is angle P located? Outside, discussion should be over if you know your rules. Should be 1/2. Do I subtract or add these arcs? Subtract if it's on the outside. All right, by the way, highlighters, colored pencils, fair game on the Regents if you want to bring them. Okay, fair game. Draw highlight the angle P. It's drawn to which two arcs here? What's the bigger one? Little help here. Angle P. Which two arcs are in between? 160. So 100 minus 60. Angle P will be 20 degrees. Okay, two more. I got RQS now. RQS. Inside or outside? Inside, ready? It's one of three types if it's inside. Is it central? No, there's no center even in this circle. Is it inscribed? No, then it's got to be a floater. How do I find a floater angle? 1/2 of adding two arcs. Okay, here we go. Which two arcs? RQS belongs to which arc? 120 plus its vertical angles arc, which is 80. So this will be 100 degrees. And then there's one more, which is usually the toughest, which is angle PTV. No. Okay, ready? What is PT? What is that line segment called? PT. That's a secant, right? And this is a tangent. Secant, well, you could kind of call it part of a chord. Never mind, you guys are going to be right. Yes, so it's going to be half its arc. So I call it kind of a chord and a tangent here. As long as a tangent, if it was a chord and a secant, we'd be in trouble. So it will be half of 80. A tweener angle. There you go. Thank you, Emma. 40 degrees. Roman, we are right there. Okay, here we go. Lightning round now. Go back to your January 2018 exam. Here we go, 16. Let's go through some multiple choice real quick before we leave. While we're on the topic of circles, let's go to another one, number 16. Read these directions carefully. We're looking for the false one here. Which one is not true? All right, number 1, is ABC a right triangle? And I want to back ourselves up with facts. Is ABC a right triangle? Okay, it is. Where's the right angle? ABC. Now tell me why it's a right angle. It's an inscribed angle drawn to a... Okay, there it is. So that's true. I don't want to circle it. I'm looking for the not true one. Is ABM, that triangle, is it isosceles? Why is this one isosceles? What do you know about AM and BM? They're radii, meaning they're all congruent, makes it isosceles. That one's true. I'm looking for the false one. All right, let's keep this train rolling. How about arc BC and angle MBC have the same measures? Ooh, not a lot of talking on this one. BC, arc BM, angle BMC. What type of angle is BMC? Central, and it's always equal to the arc. The central angle and its arc always equal. So again, I know by process of elimination what it's going to be, but some of you may think this is true. Arc AB is 1/2 of ACB. Well, is an ACB an inscribed angle? What's the problem though? The angle is equal to what? Half the arc. The arc isn't equal to half the angle. Everyone see that there? Yeah, that gets pretty tricky. If I wanted to correct this, I'd take the 1/2 and either put it over here with arc AB or change that to a 2. All right. Questions there? Next. 17. Okay, so in the givens, it told me I have right angles. I have perpendicular lines, X, Y, and RS are both perpendicular to YR, so they form right angles. Which statement is true? Who is a tough one? Anything else you can mark on your diagram? There should be one other markings you can make here. Come on. This is day. Vertical angles, yes. All right, let's stop right there. What do you already know about the triangles? Similar by what method? Angle, angle. So they're similar by angle, angle. Guys, can you get me any sides at all? Me neither. There's no way you're going to get a pair of sides here. So they're not going to be congruent, and I cannot get XS congruent to YR if the triangles aren't even congruent. So now I'm down to these two. We know they're similar. Sides in the ratio, or where did this come from, by the way? This is a product of the means equals product of the extremes. All right, hold on. I'm going to take this next level now. What would be the ratio that resulted in those two products? XY here, where would SR have to be? Diagonal. And then XZ, RZ. So basically it comes down to, out of these two proportions, which one's the correct one? Which one has the correct matchups? I'm going to leave this one up to you. Which one has the correct matchups here? Choice 4. XY does not match up with RZ here. All right, doesn't match up with RZ. Questions here. Oh, whoa. I didn't hear any bell. Let's go. 23. We got plenty of time, a minute and change. Hey, anybody just turn to that, see the diagram, and automatically know what we're talking about. What are we talking about? There you go. That's where we got to be a week from Friday. Yep, this is Hills and Sass. Right triangle, altitude to the hypotenuse. Hills and Sass. We're looking for BC. Hey, altitude involved at all? Nope. So this looks like we're going to use a little Hills up in here. Hypotenuse. What value should I plug in for the hypotenuse? 12. Leg. Leg? What? Leg? When we say leg, it's the leg of the original right triangle. Now, which segment? Not using 8. Come on, we're not using 8. You use the segment where? Next to the leg we're using. So it would be 4. There we go.